There are several pairs of angles. We have vertical angles. They will form an X. You will see the two lines right here form an X shape. Therefore, we have vertical angles. Vertical angles share a vertex or the corner, and they open in opposite directions. 3 opens to the right, opposite of right is left, and 4 opens to the left. 1 opens up, 2 opens down, so 1 and 2 are vertical angles. And one thing we know about vertical angles is that they are congruent. We can write that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. They will have the exact same measure. The next pair of angles are adjacent angles. Adjacent means next to. With adjacent angles, they actually have to share a side. Angle 5 is right here that I'm highlighting, and angle 6 is right there. So if I take angle 5 and I highlight angle 5, and then I highlight angle 6 in a different color, you will see that they will overlap. That side right there that is green is the side that they share. Therefore, that makes them adjacent. Complementary angles are two angles that will add up to equal 90 degrees. They don't have to be adjacent, but this example they are because they share this side. Complementary, you just need to remember, equals 90 degrees. Supplementary are two angles, when you add them together, will equal 180. And again, they don't have to be adjacent. This example right here, they are not adjacent, but they could be if they wanted to be. We just know that the measure of angle 9 plus the measure of angle 10 has to equal 180 degrees. If you look over here for the complementary and supplementary angles, you will see that little M in front of the angle symbol. That is read measure of angle 7, measure of angle 9. Perpendicular lines would be two lines that will intersect and create a 90-degree angle. We know that this is a 90-degree angle because it has the right angle marking right there. If we have one 90-degree angle, that means all of them where the two lines intersect will be 90 degrees. The symbol for perpendicular is right here. It looks like an upside down capital T. This reads line L is perpendicular to line M. Parallel lines are two lines that will never intersect. We know that lines will be parallel if they have a triangle of the same marking. Since both of these have a pink filled in triangle on the line, that means that line S is parallel to line T. And here is the symbol for parallel, two straight lines close together. If there is a third line that intersects parallel lines or any two lines, that's called a transversal. So line R right here is the transversal because it is intersecting two other lines. When you have parallel lines cut by a transversal, we have several special pairs of angles. A transversal, when it intersects two parallel lines, you can see that 8 angles are formed. We have 4 angles with the top line and 4 angles with the bottom line. There are 2 different sections to these lines. We have the interior, which will be these right here. So those are your interior angles. Your exterior angles are the ones that are on the outside. Since interior means inside, exterior means outside. Our outside are our 1, 2, 8, and 7. Our interior angles are the 3, 4, 5, and 6. Now, there are some more special angles that are formed. Alternate interior angles, since we're saying interior, we're only talking about 3, 4, 5, and 6. Alternate means one on each side. Now, we're going to pick one from line J, the top line, and we're going to compare it with one in line K, the bottom line. If I start with 3, 3 is on the right side of the transversal. Therefore, for alternate interior, we need the angle that's on the other side, but down at the other angle. So 3 and 5 are alternate interior, which means 4 and 6 are alternate interior. Similarly, with alternate exterior angles, now we're talking about the exterior, 1, 2, 7, and 8. 1, we're going to compare with 7 because they are on opposite sides of that transversal. They're both exterior. 2 would be alternate exterior with 8. Corresponding angles are a little different. We want them to be at the exact same position but at the other line. So if I look at angle 1 is above the line J and to the left of the transversal. So down on line K, I want the ones above K, so that's 5 or 6, but I need the one to the left of the transversal, so that limits it to just 5. 1 and 5 are corresponding. 2 and 6 are corresponding. 3 and 7, and 4 and 8. Another way to look at corresponding angles, if I pick all 4 of these angles up and I place them down on top of this other line, 1 would be on top of 5, 4 on 8, 3 on 7, 2 on 6. That's how you can tell corresponding angles. In the figure to the right, A is parallel to B, and Q and R are transversal. So A and B are parallel. Even if they didn't tell us that up here, we could tell that by the pink triangles. Q and R both intersect A and B, therefore they are the transversals. We want to classify the relationship between angles 3 and 5. Well, 3 and 5 are up here with line Q. So my suggestion to you would be to cover line R. And we look at 3 and 5, and we can see, well, they're between the two parallel lines. That means they're in the interior. One is below the transversal, one is above, so they are alternate interior angles. Alternate interior angles are congruent, therefore 3 is congruent to 5. Same set of lines as the last example. This time we have the measure of angle 15 right here is 78.5 degrees. We want to find the measures of angle 11 and angle 9. Again, you might want to just cover that top line so it's less for you to look at. Now, I know that angle 15 and angle 11 are corresponding angles. And just like alternate interior angles and alternate exterior angles, corresponding angles are congruent to each other. Therefore, 15 and 11 are going to be congruent. They will have the same measure. So 11 would be 78.5 degrees. Now, 11 and 9, you can look at it this way, are vertical angles. Here we have that X. So therefore, they are also congruent. The other way you could look at for 9 is 15 and 9 are alternate exterior angles. All 3 of these angles will have the exact same measure. So all 3 are 78.5 degrees. In this example, we have angle ABD, this whole angle right here, is 164 degrees. We want to find the measures of angle ABC, which is part of the entire angle, and we want to find the measure of angle CBD, which is the other part of the angle. What we can do is we can set up an algebraic equation. We can take the measure of angle ABC and add it to the measure of angle CBD to give us the whole angle, which we know is 164 degrees. Here we are filling in the parts that they gave us. 2x plus 23 plus x equals the whole thing. We combine our like terms. 2x plus x is 3x plus 23. Subtract 23 from each side to get the 3x couple alone. Divide by 3. And we find that x is equal to 47. Now, we need to find ABC and angle CBD. Well, CBD is easy since we found x. We know that CBD is 47 degrees. To find the other angle, we take 47 and we're going to plug it in for the measure of angle ABC. 2 times 47 plus 23 is equal to 117. Angles RVT and UVW are vertical angles. We have the measure of angle RVT is 3x degrees, and the measure of UVW is 5x minus 36 degrees. We want to find the value of x. We don't have a picture, and if you'd like to draw one, you're more than welcome to do that. But what we need to know is that vertical angles are congruent. They equal each other. All we need to do is set up the equation 5x minus 36 is equal to 3x. We want to get our like terms together. Move the 5x to the other side. Then we want to break up the couple, and we find out that x is equal to 18. Once we find x is equal to 18, we want to find the measure of angle UVW. All we need to do is take 18 and plug it in for x. 5 times 18 is 90. 90 minus 36 gives us 54, and we put the degree symbol.